Introduction to Project BEAM. Welcome to Project BEAM, Be a Mathematician. Project BEAM is a 5-year research project funded by the U.S. Department of Education Jacob K. Javits Gifted and Talented Students Education Program, award number S206A1714. Overview of presentation. In today's presentation, we will learn about background problem, project goal, locations, identification, research design, math group, and comparison group. We will also answer any questions you may have. Background problem. Minority groups have been traditionally significantly underrepresented in gifted and talented education, also known as GATE programs, as well as science, technology, engineering, and mathematics STEM fields. The goal of No Child Left Behind, which ended in 2015, was to narrow the achievement gap among demographic subgroups of K-12 and bring a large proportion of students to a basic and proficient levels of educational attainment in national and state assessments. However, differences between subgroups of students performing at the highest levels of achievement, especially among minorities, have received little attention. According to the U.S. Bureau of Labor Statistics in 2017, the STEM workforce will grow faster than any other sector in the coming years. However, in terms of demographics, Indigenous and Hispanic population is significantly underrepresented in STEM fields, and their underrepresentation has been a growing national concern for over a decade. Indigenous and Hispanic students tend to take fewer advanced math courses than their peers, and there is limited access to advanced math nationwide. In addressing the underrepresentation of target students in GATE and STEM fields, algebra is considered a gatekeeper course of STEM pathway, which means students must master this content before they will be successful at not only higher level math, but other STEM courses. Project goal. The goal of Project BEAM is to increase the number of mathematically promising middle school Indigenous or Hispanic students. We define mathematically promising students as those who demonstrate high levels of math achievement and real-world math application skills, participate in a gifted math program or club in middle school, complete an advanced math class in middle school, and intend to or actually enter a science, technology, engineering, and mathematics STEM honors certificate program in high school. Locations. This project is a multi-site study. The project aims to target 540 7th and 8th grade Indigenous or Hispanic students at 18 middle schools in Hawaii, Arizona, and the Commonwealth of Northern Mariana Islands, CNMI. 10 schools are in Hawaii, 2 schools are on the CNMI, 6 schools are in Arizona. The headquarters is located in University of Hawaii at Manoa Center on Disability Studies, and we are collaborating with Northern Arizona University and Northern Marianas College. Identification. We use a non-traditional approach to identify 7th or 8th grade students with potential in mathematics through a 2-step procedure. First, Native Hawaiian, Native American, Pacific Islander, or Hispanic 7th or 8th graders who have received A or B in a math course prior to his or her algebra course will be selected. From the pool of students, we will administer the Multiple Intelligence Developmental Assessment Scale, MIDAS, to students, Scales of Identifying Gifted Students, SIGS, home scale to parents, and 6 school scale to math teachers. Students rated to have a high potential, aptitude, and interest in math in any of the 3 scales will be invited to participate in the project. Now we will look at the research design. As for a research design, we randomly assign schools into 2 groups, intervention group and comparison group. Then we recruit students through the schools and focus on student outcomes. Intervention group receives 60 hours of math intervention based on the BEAM model. Comparison group receives 60 hours of academic support in the non-STEM areas such as social studies or language arts. We will now look at the components of intervention and comparison group. Let's first look at the math group and talk about the BEAM model. What is the BEAM model? The BEAM model is based upon 3 evidence-based models: Renzulli School-Wide Enrichment Model, Capilina Model, and Ne'epapakahana Model. The BEAM model provides academic acceleration and enrichment in mathematics, cultural, and problem-based hands-on learning and blended learning. Participating students will work with mentors for 12 weeks or 60 hours. There are 8 components that support the model. Let's look at the first component, Component 1, Math Exploration. For 30 minutes per week, students will be exposed to STEM community building activities, role model interviews, math career exploration activities, learning how math is everywhere, math behind music and sports, and math in different cultural contexts. Component 2, Collaborative Problem-Based Learning Practices. Students will learn how to solve real-world problems using math skills and work collaboratively with their classmates through an online platform. Their mentor or tutor will guide them through a critical thinking process in order to identify real-world problems and work towards a solution. The 4 real-world problems that they are exploring are climate change, plastic pollution, overfishing, and agricultural innovation. Component 3, Math Project Development and Learning Profile. One of the first things that our students do is utilizing Renzulli Learning System, a web-based program that can recommend online activities and resources based on who they are. First, our students get to know themselves better through their individual student profile. Through this profile, they become more aware of their top 3 interest areas, learning preferences, and how they like to express what they know. In the screenshot above, this student is interested in technology, science, and math. She expresses herself the best verbally, such as speeches or debates, hands-on activities such as making 3D models or conducting a lab experiment, and audio-visual displays like graphic blogs. She also discovered that she learns best through discussion, lectures, and games. Students utilize this knowledge to select a topic for their math project based on their interest areas and then present their project using one of their preferred expression styles. Now we'll continue with Component 3, Math Project Development. After the students receive their profile results, online activities and resources of different types are recommended to them from a database of over 40,000 internet sources that has been already vetted by this education company. We guide students to use the program following Renzulli's enrichment triad model. First, students will explore Type 1 enrichment activities, which are exploratory and designed to expose the students to a wide variety of disciplines topics, occupations, hobbies, persons, places, and events that are not covered in the regular and traditional curriculum. These include virtual field trips, real field trips, websites, fiction and non-fiction books, summer programs, online activities and classes, and video and DVDs. At this stage, students will explore and choose a real-life problem of their interest. Then, students move on to Type 2 enrichment activities, which are designed to develop their creativity, problem solving, and critical thinking skills as well as research skills. These include creativity training, critical thinking, how-to books, and research sites. At this stage, students will learn and practice to apply problem-solving steps. Type 3 enrichment activities are individual or small group investigations of real problems based on students' interests and skills, with the aim to produce a product for real audiences, and gradually they select their topic for their project. At this stage, students will find the best solution to the identified problem as applying mathematical procedures and thinking as a small group or alone and with mentor guidance, and present their project to the public in the end. Student projects can take a variety of formats because students choose how they want to express what they learned. Students can also submit their projects to our online math project competition. The winner will receive a scholarship. Component 4. Online math program use. In addition, we ask students to use a math online program for 1 hour per week. It provides individualized math acceleration appropriate to one's own math level. Component 5. Hands-on culture-based math activities. This is the core of our program, which is our culture-based, hands-on math activities. Students develop their math skills through culturally relevant and interactive manners. This will help them solidify their understanding of math and how math can be fun and applicable in their life. Activities include topics on solar energy, building a canoe, computer programming, and sustainable farming. Component 6. Service learning. Parents, mentors, and students will be invited to one of our service learning days. Service learning projects will be another fun way to utilize their math skills to help others, community, or the environment. This will be an opportunity for them to see how math can be applicable. Component 7. Parents and children together. Parents, teachers, and community members will be invited to our 5 parent workshop series. Each workshop will last 2 hours and cover different topics such as gifted minority students and evidence-based algebra teaching strategies. For the second part of the parent workshops, parents will learn culture-based hands-on math lessons that they can do at home with their children or students. The purpose of these parent workshops are to connect parents and children together and build a community of learning at home, as well as to bridge home and school. Parents, teachers, and community members who went through the workshops are then invited to serve as volunteers in our students' classrooms when they work on their math projects. Component 8. Advisory Board. Project BEAM has an advisory board composed with gifted education specialists, cultural experts, middle school math experts, ethnomathematicians, and indigenous education experts from Hawaii, Arizona, and the Commonwealth of Northern Mariana Islands. The advisory board shares the vision, guides cultural adaptation of the lessons and assessments, supports the recruitment of and access to community, schools, parents, and students, and collaborates to disseminate the products. Finally, we will discuss about comparison group. For the comparison group, they will meet as a class, and our project mentor will guide students to select top 2 areas they need to work on more amongst a list of non-STEM, social studies, and language arts subjects. In reviewing the weekly areas in their syllabi of the 2 subjects, students select one of the 2 areas to study each week and develop an individualized study plan. Each week, there are 2 large learning stations by topic. Students first study a topic independently with given resources. Then, they come to a small group and share what they learned and deepen their understanding through collaborative activities and discussions. The mentor reviews weekly main questions with all students in each learning station. If you have any questions, please let us know now. Here is our contact information. Our website is www.cds.hawaii.edu/projects/beam. Email javitsprojectbeam@gmail.com.